Hey everybody. Today we're talking about unusual observations in data sets with two variables. We're going to talk about discrepancy, leverage, and influence. In a two-variable data set, individual points can be unusual in their x values, their y values, or both. Technically, an outlier in a set like that is an observation whose y value is different from the general trend of the data. That is, it's a point with high discrepancy. Sometimes in the real world, people use the word outlier more loosely, so be ready for that. For instance, here are three plots, each of which includes an unusual observation. Only the first two show outliers. If you look at either one of those and consider the unusual value and its relationship to the regression line, it's either very much above it or very much below it. The unusual point in the third plot here on the far right is actually very close to the regression line that we drew, so technically it's not an outlier in this sense. Observations that have unusual x values have greater potential to affect the fit of the model, and we say such values have high leverage. The leverage of a point depends only on its x value. So looking at those same 3 points, only the two plots on the right have high leverage. The first one does not, even though it has high discrepancy. Again, only looking at the difference in the x values here. An observation that substantially changes the fit of a model is said to have high influence. So in this illustration, I've drawn two regression lines. The bluish one is in the situation where that outlier is not included in the calculation for the regression line. The orange line does include that outlier, and you can see that the model changes substantially when that outlier is included or when it's taken out. Typically, an observation has to have high discrepancy and high leverage to be influential. That is, it has to be different, very different in the x direction, and it has to be far away from the fitted value for that x value. Now, each of these concepts can be quantified, although I'm not going to do that here. Discrepancy is often measured using studentized residuals, sort of standardized residuals. Leverage can be measured using hat values, and influence can be measured using Cook's distance.